Hello dear students, how are you? I am Vivek Sharma, your mathematics teacher. Today we are starting chapter number 3, pair of linear equations in two variables. Before going into deep in this chapter, please like, share and subscribe my YouTube channel. Introduction is given. What is given in the introduction? Here the definition of linear equation in two variables is given here, which you have studied already in your 9th class. Again, I am repeating this definition for the clearance of the topic. An equation which can be put in the form ax plus by plus c equals to 0, where a, b, c are real numbers. We know real numbers are those numbers which is composed of rational and irrational numbers. Here one condition is given, that a and b both are not equal to 0. Then such equation is called as linear equation in two variables x and y. Here example is given for your clearance. 2x plus 3y plus 7 equals to 0. Any equation which is written in this form represents a linear equation in two variables in x and y. If we want to represent such equations graphically or geometrically, so it always represents a straight line on the Cartesian plane, and we know that a Cartesian plane is made up of x-axis and y-axis. And if we want to find the solution of linear equation in two variables, so there corresponds a point. Always we get a point on a line which represents the equation and vice versa. Now in this chapter we will looking for pair of linear equations in two variable. So here first topic is the simultaneous pair of linear equation in two variables. Here the definitions of such type of equation is given. A pair, what is written? A pair of linear equation in two variable which is written in this form. Here a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0. Then such equations are called simultaneous pair of linear equations in two variables. Means always these types of equation written in pair. For example, 2x plus 3y plus 7 equals to 0, 5x plus 3y plus 8 equals to 0. Both equations are written simultaneously, and x and y both are same variables with the common degree 1. So if we want to represent these equations graphically on a Cartesian plane, so we always get two lines, two straight lines on a Cartesian plane. So in this case there are three possibilities here, that two lines will intersect or two lines will not intersect. They may be parallel or they are parallel, or these lines will be coincident. So from last slide we have seen that this pair of linear equations in two variable has two straight lines which may intersect, may be parallel or coincides, okay, or coincident lines. Now in this slide we are here representing the lines graphically. In first graph you see that there are intersecting lines, means that lines may intersect each other. In the second graph we are watching here the two straight lines are parallel to each other, means that may be parallel. Or in last graph we see that these two lines are coincident lines, means that they may be overlap to each other. Okay, so here we get the conclusion that when the lines are intersecting, it means that we have a unique solution. When the lines are parallel graphically, so we have no solutions, and when the lines are coincident lines, so it may have the infinite solution. So here we will discuss some daily life examples for clarification of concepts, how to represent these situations graphically and algebraically. The first example is here. Aftab tells his daughter, 7 years ago, I was 7 times as old as you were. Then also 3 years from now, I shall be 3 times as old as you will be. Represent these situations algebraically and graphically. So here a aging problem is given. Now when the word ago or before comes, so in that case we will always subtract the given years from the percentage, and the word hence is come or now or after, then we will add the given years in the present age. So let's start. So let we consider the age of Aftab, present age of Aftab, and his daughter is X and Y. Now in situation first, 7 years ago. So we will subtract 7 years from the present age of Aftab and the present age of daughter. So we will get the age of Aftab will be X minus 7 and age of his daughter is equal to Y minus 7. Now according to given condition that Aftab 7 years ago was 7 times as old as his daughter. So it means that Aftab age becomes 7 times of age of daughter. So it equals to X minus 7 equals to 7 times of Y minus 7. And on solving this equation, we get X minus 7Y equals to minus 42. Now let's come on condition number 2. 3 years hence. It means we are talking about after 3 years. So we will add 3 years in the age, present age of Aftab and the present age of daughter. So we will get the age of Aftab will be X plus 3 and age of his daughter will be Y plus 3. Now according to given condition that after 3 years the Aftab age becomes 3 times of his daughter age. So it equals to X plus 3 equals to 3Y plus 9. Now if I want to represent these situations graphically, geometrically, so we have to make solution table for each equation. Now we have a pair of linear equation in two variables and each linear equation in two variable represents a straight line. So I take each equation one by one and try to find the solution table for making their graph. First I take the equation X minus 7Y equals to minus 42. I can write this equation as X equals to minus 42 plus 7Y. Now the solution table for it, when I take Y equals to 5 and putting that value in the given equation X equal to minus 42 plus 7Y, on solving that equation I get the value X equal to minus 7. If I put Y equals to 6 in the given equation, so I get value X equal to 0. If I put Y equals to 7 and I just put this value in the given equation X equal to minus 42 plus 7Y, so on solving that I get value X equal to 7. Similarly, if I take the equation X minus 3Y equals to 6, so I can write this equation as X equals to 6 plus 3Y, and the solution table for this equation is here. When I put Y equals to 0 and putting that value in the equation X equals to 6 plus 3Y, on solving it I get the value X equals to 6. When I take value Y equals to minus 1 and put that value in the given equation X equals to 6 plus 3Y, on solving it I get the value X equals to 3. And if I put the value Y equals to minus 2 in the equation X equal to 6 plus 3Y, on solving it I get the X equals to 0. So here this graph which is showing in front of you tell you that how can we represent each equation graphically. Two straight lines passing through different point represents the two situations graphically, and in different graphs when we plot we get different situations. Now let us take another example for clear understanding of the concept. The cost of 2 kg of apples and 1 kg of grapes on a day was found to be rupees 160. After a month, the cost of 4 kg of apples and 2 kg of grapes is rupees 300. Represent the situations algebraically and geometrically. Now we consider the cost of 1 kg of apples to be rupees X and the cost of 1 kg of grapes to be rupees Y. According to the question, the algebraic representation of two situations is 2x plus y equals to 160 and 4x plus 2y equals to 300. Now if we want to represent these equations geometrically, so we have to find the solution table for each equations. First we take equation 2x plus y equal to 160 and I can write this equation as y equal to 160 minus 2x. Now if I take x equals to 50 and put that value in the given equation y equals to 160 minus 2x, on solving that equation I get the value of y equals to 60. If I put x equal to 60 in the same equation, I get value y equals to 40. Similarly, if I take x equal to 70, I get value y equal to 20. You can put another values of x and you can get the values of y. Now for equation 4x plus 2y equal to 300, and I can write this equation as y equals to 300 minus 4x by 2. If I take x equal to 70, so I get value of y equals to 10. If I take value x equal to 80 and put in the equation y equal to 300 minus 4x by 2, so I get value of y equal to minus 10. If I take x equal to 75, so I take value y equals to 0. Now the graphical representation of these equations is in front of us. Here we can see that we are getting two straight lines which are passing through different points, and here we have the two straight lines for two different situations, and on the basis of this we can represent many real life situations algebraically and geometrically. I hope you have understood this concept. Please do some questions related to that concept in homework, and I have uploaded the PDF in the form of notes for this concept for the clear understanding and some questions.